Okay, so yeah, I'll be recording with another third-party tool which I have already started. So I will share my screen here. Same screen we are recording. So if you can see my screen, then well and good, we should be able to kick off. So you can see my screen, right?
Yes, you can.
Okay. Okay, now, yeah, today we are going to focus on data modeling. Why it is important to model your data. Remember, when we collected the data from wherever it was, we did the cleaning, we did the transforming, we did whatever we needed depending on the goal. Before you joined, Linda, I was showing, I think it is also important to go through this, or to just give you a hint on this, that whenever you start off with, is my screen still visible?
Yes, it is.
Okay, that I was meant to share the whole screen. Now, Linda, whenever you're starting off with a project, I'll share with you this template. I've been using it for several years. So whenever you start a project, there are things you don't have to take lightly, mostly in planning. That when you start a project, you don't have to start directly on data preparation, or you go directly to dashboard development. There is this checklist which I'll share with you, that whenever you think of starting a project, there are a lot of things that are involved in planning. Talking to the stakeholders, gathering the KPIs and all that. Then who is going to access what? Then you start now the data preparation, the source, the extraction, the cleaning, the modeling, the integration, that is in case you integrating data with a different sources, or the internet, or it is a an SQL database. Then loading everything into Power BI, then doing a documentation on where you got, because you remember, if you get data from different sources, you have to document with those URLs where you're picking that data. Because you'll wake up one day when that data is broken and you can't remember how you linked to it. So you do that documentation in the stage of preparing data. Then when you're done, you design a dashboard before you develop it. It can be a scribble or a scratch on the book and put together that we are going to have this page, we shall have this visual here, we shall have this here. Like, you put everything on a mock-up before even you go to developing. You look at what are the brand colors, you look at what charts will be in the dashboard. How do the users need to interact with it? Do we need buttons? Do we need slicers? Do we need drill downs? Then the accessibility and how it is going to be used. The people who are going to use this dashboard, are they tech savvy, or are they good? Have they used Power BI before? Something like that. Then you go now to developing the dashboard. That when you reach this part of developing, it becomes easy. You already know the people you're developing for, whether they're executive, whether they're operational, or it is people who will just need one button every morning to click on and see the results and go and do whatever they are meant to do. then when you have that checklist, it becomes easy for you to deploy something that is going to be useful for some good time. And it is going to be useful maybe in data-driven decisions. Then after you have published, then you look at the ongoing monitoring and maintenance. In case it breaks, what do I do? Do I have a backup that I will be working with one of the backup to create updates as they are using the old version? That's what I was telling Pius before he joined on version control. You never have to develop or work in a file where the users are already updating. You work with a different version such that when you're done, you replace it with what they have. They see all the updates at once. Rather than working in the file they are already viewing, that when you change the header, someone who was looking at the header, they see it changing there and then without you telling them that you are deploying changes. It becomes hard for your users to maintain the adoption and the usability of the dashboard you have given them. So that is a checklist that it gives you at least some mileage to engage your stakeholders. And you also buy time to see what you don't have before you sit down to create anything. So I think I can share it right now before I forget. Linda.
Question, does this checklist work on any Power BI that I'm working on, that I can use it as a checklist before, as I work along?
Yeah, yes. And the checklist has a lot. You don't have to check everything. It depends now, you determine the type of project you're running, because developing a dashboard is a project. Because you have to start, you have to end it in a given time, you have to use a budget has to be specific, the stakeholders have to be on board, all that. The moment you get that right, and some of them you may, for a given project, you can always create a copy and this remains your master. That whenever I start a project, I rename it and remove what is not necessary for that project. If I don't need to do research about the data sources and all that, remove it. Then here, there are links of articles and blogs you can read about that, like that item. So it will also give you a mileage on learning more on how some of the things are done, such that with time you'll start managing projects of developing dashboards rather than you developing them, so you know what is always meant to be done before anything else. So there are a lot of blogs and articles and all that. You can go ahead and read notes on those descriptions. So you don't need to check everything for every project. Some of the projects you'll find that on planning you need like around 3, 4, 5 check boxes, but just to know that there are items that exist in projects which are maybe bigger than what you're working on. So
okay.
Yeah, so I think that's it. I may no longer need this. Okay, now today our focus being on data modeling. One, we are going to look at what is data model, and these days the name has changed. It's called a schematic model, a schema, S-C-H-E-M-A. Actually it's here, a schematic model. So when we go into one service, you'll see the name has changed. Like for a year now, it's called either schematic model, schematic diagram, something like that. But obviously, the model, data modeling, remains as the native. So we are going to look at what is the difference between fact and dimension tables. Then we are going to look at one of the prominent model, which is always called a Star Schema design. Then we have creating table relationships in model view. So we are going to see how we model those tables we have extracted from the different sources and make all of them related before even we kick off the project, such that you know that whenever I start the analytics, all the data I'm working with is related. And what relates those models, obviously they are keys, primary keys, foreign keys, we are going to define that. Then somehow we are going to define what is cardinality. When you hear of someone talking about one to many, many to one, what does it mean? We shall look at how we build a date calendar or a date table, or we call it a calendar table. Whenever you're starting a project, whichever project you're working on, you always as a must have a calendar table. So a calendar table defines a lot, and we shall look at that. Then the naming convention. When you're doing your naming, do you use an underscore? Do you use a hyphen? Do you use space? We are going to look at that. The disadvantages and advantages of using either of those. We are going to look at that. Then we may not touch the AI assisted today, but at some point when we are doing a full project, we are going to look at how AI can assist you to run some of the relationships in case you're dealing with big data or a lot of files that you may take time to define the relationships. Then obviously at the end of today's still you'll take up an exercise, an assignment for you to do or to try out, which will open your quiz, which will activate the quiz 3. So I will rush through the notes I had created here. I think it is no longer now news that you need now to use Notebook LM. By the way, on 16th it was changed from Notebook LM to Gemini Notebook. So it means now the change came to make sure that Google wanted to make all their products in one ecosystem, because this Notebook LM started in 2023 like a research tool, but now it has been upgraded into the AI ecosystem. That's why they have changed this name to Gemini Notebook. I think even I shared a LinkedIn post on that. So we are focusing on data modeling and created slides from the sources we did last time. I think we were together. No. It was another team. So if you have not been with us before, how we pick these sources, we said that here you can insert any sources, you can upload files, you can get links from either YouTube channels or any blogs. It can even be a LinkedIn post someone posted and you want to deep dive into it and get more knowledge about that. Or it can be a OneDrive file, or you may have copied text like how we do from our own site this side. So when you have done that, this time I think I had pulled 2 videos from YouTube. So if you click on them, you should be looking at the thumbnail down here. This is it. You'll follow this guy. He's Data and Bra. He's good at explaining data analytics with a lot of animations and all that. Then another one was from the data and the AI guy. He's also good at explaining things into depth, not just rushing them on top. He explains like data modeling for like a 2-hour video, and you feel like, yes, this is it. Though we may not have the 2 hours to watch that video, so you can always pull it into Notebook and it will always give you a summary. So this is what we are going to look at. First of all, we are looking at what is data modeling. Data modeling is basically creating relationships amongst your data, if you can take it that way. There may be many definitions outside there, but that's it. So getting insights from the data you have. First of all, here they are showing us two kinds of data models. We have one that is wrangled, and this is the way our data looks like in the model when we have just extracted them from wherever we are getting them from. You find you have tables all over. Some of them have already showing you errors. Maybe they didn't extract well. Some of them are still loading. Maybe you have loaded a web link that is still loading for the last 2 hours. This is the wrangle you have. And you look forward always to make sure that your model is in this format, where each table is related to the other. Mostly, we always have fact tables in the middle and dimension tables aside, which is a star schema. I'm going to explain that. So these two tables getting related to each other, there is always something common that relates them. That you find there is a column here and there is a column this side that relates the two tables. And when they are related, it means that that data becomes one. It's like a relationship in marriage, that when you are related, there is something in common that brings you together. Either it was beauty, or it was character, or it was discipline that was bringing you people together. The moment you get related and you get engaged, you get wedded together either in church or civil, you become one. That's why we say this model is one. That whenever I pick here the region and I put it in a table somewhere in my visuals, I can come this side and I pick the customer and it will automatically relate, because this location is related to the, this location is related to this customer, let's say, through the fact table. There is something here in the fact table that is relating these two. Maybe it is an order, and that order has a region here, let's say Kampala, and that order has a customer who is maybe Sabiti. So it means that this one gets related to this. It means when I pick something and I note out Kampala, I will get the customer name who was from this side. And why do I get the customer name? Because I already have a relationship. That is simply how you can explain it. So now there is always a cost you run with if you don't model your data, and that cost is always heavy. You find that your data is breaking unknowingly. You're pulling things together, but you don't get the numbers you expect to get. You know that the company has 3 branches, but when you try to pull data into a scorecard, it is showing you 9 branches. And the 9, because there is a 3 multiplying somewhere which you don't know where it is coming from. Why? Because your data is still a nightmare. So the root cause here is direct connections to the raw, because you're connecting the data directly to the raw file. Maybe it is a Google Sheet, maybe it is an SQL database. So at the end of the day, you find that your customer table is never connected to the regions table, is never connected to the products table. You pick here an order, but that order comes in the table, but you fail to pick the product name. It remains giving you the product ID. Or you fail to pick the region where that customer is coming from. Or when you filter for the region, that number of that customer doesn't appear in the totals. That's what happens. What comes with that? Duplicates. You get highlight and says when you're loading a file and it takes years and centuries to load. I know when I talk about that, Pius knows. We have a story behind that. So then silent breaks, exactly what I've talked about. You're connecting your customers, your products. You pick the customer and put it in a table. You pick their sales total revenue, maybe from that customer, you put it in a table, well and good, the number displays. But you reach a point of filtering out a specific product. You need to look at each customer's sales. How much do we do for that specific product? And everything in the dashboard breaks. Like you see errors everywhere, you see blanks everywhere. Meaning, your data modeling is not right. Your relationship is not right. Just imagine that the human relationships never appeared to be there. That Chris, right now, I would wake up, I find myself in Mubende, and I have a wife in Mubende who I don't know where the wife comes from. The next morning, I'm in Tororo, I have someone else, I don't know where the native, where that person comes from, the tribe and everything. It would be chaos. But because we have learned to follow that lineage, to know where everything comes from in that direction, it becomes easy for us to trace back. That even our kids can trace back their original, the grand. And now this is now the healthy data model. Now on the healthy data model, that's where we find a deliberate structuring. So most of the cases we look at, you see how this is? If I can annotate it, maybe then it will explain exactly what I'm going to talk about at some point in future there. So when you look at this, starting with this, we have a table in the middle which they call a fact table. I will explain what a fact table is. Then here we have dimension table. This one maybe is a product. This one maybe is a region. Here maybe we have customers. Here maybe we have subcategories, something like that. So at the end of the day, what I've drawn here is a star, right? This is a star. And that's why this model, that's why this model is called a star schema model. When you have 1 or 2 or 3 fact tables, it is not always a must that it has to be one fact table. I will explain what a fact table is just in the next presentation. Then dimension tables. Now, dimension tables are tables that have qualitative data. Qualitative data is you have a customer. In the customer's table, there is a customer name, there is the age of the customer, maybe the tribe of the customer, the region where the customer comes from, whether the marital status of the customer, name them, a lot, the phone number and everything. All that is qualitative data. Then in fact tables, we find there at least there is always quantitative data. It can be quantities, it can be sales, it can be taxes, it can be discounts, it can be anything that can be aggregated is what we refer to quantitative data. So any table you always find quantitative data, it automatically becomes a fact table. So now start looking in your projects you have been running. Which are fact tables, which are dimension tables. I know you can have definitions for these, but that's how I need you to take it. And every time you remember what is fact and what is dimension, remember that. Then another difference that lies between the two. A fact table is a table that is regular, is normally updated, like a sales table. Even now we are speaking, an e-commerce business is receiving an order in this table. Like every minute there is an update, an entry that is coming in. But in dimension tables, you can even spend 5 years without updating a dimension table. This can be like branches. It can be customers. You can even spend a month without getting a new customer, and you're working with the other customer. Still, it remains to be a dimension table. What else? There are a lot. There are a lot you can define them, as long as a table is not frequently updated. Still, it stands to be a dimension table. But still, the two differences should run together. Even if a dimension table is frequently updated, but with qualitative data, it remains a dimension table. So, first of all, single source of truth. When you have such structure that you have done a modeling, you have a single source of truth that when I pick here an order, it comes with a customer name, it comes with the region where they stay, it comes with the product name, it comes like everything, the pricing and everything. When you're dealing with data that is related like this, it is very light. First of all, even in refreshing, it is very light. And when you're running queries, it's highly compressed. Highly compressed means that when I run a query here of a customer, and I pick a customer and I pick quantities here, it will automatically give me the sum of those quantities related to that customer. But imagine here you have a table from a customer table from one sales rep who left the business, another table from a customer table for another sales rep who just joined the business 2 months ago. It means that you have duplicate data already, of which this data, these two tables must be harmonized together. But here, you will have already done that. That's the compressing we are talking about. Scalable architecture adopts to new business rules, that when there is a new table that is coming in your data set, it is very easy to know this table is related to which in the existing model. But just imagine you have been given a new table here. It is another scribble that you are going to run with. This is where you find things in a business and they tell you that if it is working, don't touch it. Because the moment you touch one line, everything is gone. So, and we don't want to run with those models. Make sure that touch it, put the business downtime like 2 days when you know that you're looking at something that is sustainable. Okay, the data modeler's life cycle. When you're doing your modeling, what's the life cycle you go through? We start with conceptual modeling. This is where you gain ideas from stakeholders. You sit down on a round table and you talk about things. Ideally, you have not done any mapping. What maps to which? Then the second level, you have the logical modeling, now establishing the identities, the keys, and all that. To know that in this table, there is a customer ID, and in the other table, there is also a customer ID, but with a customer name. So I can use the two to link them to get the other customer name, like how you do VLOOKUP. So on the third, there is a physical modeling. Now you sit down and go to Power BI and do the physical modeling. You start indexing them together, pulling out the data types and all that. That is creating the schemas. Then the fourth is the ongoing governance maintenance. Remember that you can't do governance if you have not done the right modeling. And data governance right now is a hot cake. Because of AI, there is that data privacy has scaled up. That you knowing data governance, you become, you have the right model as the emerging trends right now in data. So the ongoing governance, you can't do row level security. We call this one, you'll always find it as RLS. Row level security means that if I create a dashboard, Linda can only access procurement data. Pius can only access sales data, but they are having the same dashboard. That is what we call row level security. Row level. It means that I'm going to give you I'm going to create a secure access that you only access transactions where your name is tagged. So that is now, when we come on the blueprinting, that is before we have talked about the conceptual view. When you're speaking with anyone on round table, whether it is your boss, whether it is in an executive meeting, They are discussing how you're going to create a dashboard. For you, this is what you scribble in your notebook. They are telling me that I'm going to do maybe a sales analysis. There and then I'll put, do we have customers table? I draw it down. This customers table should be linking to transactions. Every transaction. Now your mind runs what you're going to ask the stakeholders. Every order that comes through, does it have a customer ID? Yes. Okay. Every order that comes through, does it have a product ID? Yes. Then can you give me a table of all the customers you have in the organization? Here it is. Can you give me the product listing of all the products you have listed that are on the catalog? For the customers are booking. Here it is. This is your scribble. This is the conceptual view. Then there is a logical view. Now you as a data analyst, you sit down and start looking at the logic. The customer ID, the customer table that I've given me has an ID. That is the important thing I need. And this has to be a primary key. Why do I call it a primary key? It has to be unique. Yes. I don't need a table of customers where a customer appears 3 times because they were recording the 3 times. Every year they were recording different data from that customer. Then I don't need that. Which means I'll remove the column for year because I don't need it. Then I run remove duplicates. Then I'll remain with 1 customer ID. Then the table that records orders, that's a fact table. Do we have an ID that comes with the order from the system? Do we have an ID that comes with the product ID? Because I have the product ID the other side with all the details pertaining that product, the SKU, the category, the unit of measure, name them. Then me, I know how I'm going to connect this. Connecting this now is the physical modeling. Physical modeling, that is consolidating all the tables together, shaping them together, making the appending and everything and the merging. We did that in transformations. In other words, this is the transformation you do. Then after that, you have done all the modeling and name them. As you even build the dashboard, even as you have finished developing the dashboard, you must make sure that maintenance is easy. That whenever there is another file that comes in, it is easy for me. I have already automated that. That is on maintenance. Manage data change captures. If data changed, do I capture this in my models? Then what I've talked about, governance and all that, and the policies and marking who sees what, on the data integrity, that is also there. So I think I'll skip this. No. This is, now, I had explained about what is a fact table and what is a dimension table. When you reach data modeling and you don't know, or you're still confusing fact table and dimension table is the difference. You're still confusing what is a primary key and what is a foreign key. You're still confusing what is cardinality, 1-on-1, 1-to-many, many-to-one. Those 3 parameters, the moment you still have confusion on those 3 parameters, it means that you haven't got data modeling to its basic. So those are the things you always have to look out for to make sure that you understand them clearly. Not understanding the definitions, understanding them relating to the data you're holding. The moment you have data sets and you can't tell that this table is a fact table and this one is a dimension table, then there is still a problem. It means you still have to engage your stakeholders more to give you clear guidelines on which table is updated when. Which table, if you have a product table and they are giving it quantities, and yet in the fact table or the sales table that they have shared with you has prices, doesn't have the quantities. How do we log quantities on the dimension table? That's the question you have to ask. Why is it that when the system books an order, the quantities go in another table and maybe the revenue goes in another table? Those are the flaws that you correct, you as an analyst or a business intelligence analyst. in case you carry the role. Okay, fact tables we said, it's called the events of transactions. I talked about that. It's where events log every now and then. Then this side, it is the context describing the events. Here, it's where you find a customer table. A customer is being described from column 1, 2, 3, 4, 5, his phone number, the age, and all that. That's the context describing that. Then, contains quantitative measures, prices, units, and foreign keys. Foreign keys means that it is a primary key in the dimension table. That this side you have a product ID, this side a product ID is a foreign key. Because it is going to appear more times, more than once, but a primary key appears only once. Then obviously here it contains descriptive attributes like names, locations, categories, blah blah blah. The behavior, fast growing, deeply detailed, narrow in column count. It has few columns. You'll always find like it has 5 to 6 columns. Then this one, its behavior is slower growing. I told you that you can take 5 years without updating the branch list because the company has not opened another branch for the last 5 years. Then highly descriptive that you'll find a customer has like 15 columns describing the color, the age, the phone number, the address, the husband, spouse, children, blah blah. So those are the 3 things you can use to differentiate what is a dimension table and what is a fact table. So here they are giving us a claim, a notice that a factless fact, a specialized bridge table containing only keys mapping relationships, e.g. campaign coverage with non-numerical measures. That is now a dimension where you find that you have a fact table that doesn't have any numerical measures. Okay, this is already what I've talked about. What is a primary key and what is a foreign key? A primary key, 1, it's unique. Non-repeating identifier within a single table. The company you have worked in or the company you're in, when they enrolled you as an employee, they gave you an employment ID. That employment ID, even if you left today, it will never be given to anyone else because it carries your data. And that employment ID appears only once in that system. That is a primary key. A product ID, a customer ID, whichever ID you're talking about, it will always appear once in that table that captures the details. Then a foreign key, when your name appears in the finance books, the system doesn't replicate or doesn't write your name in the finance books. It writes your employment ID. It means that if you are receiving allowances every week, there is a transaction that is capturing every week with your employment ID, but without your name, right? So it means that your employment ID will appear in the finance books many times. Even though this side it is a primary key, in the finance books it is a foreign key. Just take an example that this is HR data set, where your employment ID is a primary key, but in finance or in operations or in procurement or in supply chain, wherever you're doing business, it will always be a foreign key. So just to reference the primary key in another table. Then there is natural key, which we call an inherited. Like if you're creating invoices, they become inherited keys. That you create an invoice, then the invoice will split into 2 lines because it is having 2 products on it. However much the invoice number is a primary key in the invoice table. But when you go to a table that shows all the sales, categorized per product, you'll find that invoice will split 3 times because that order went out with 3 lines of products. I don't know whether you get it. So that is, yeah, then there is surrogate key, the system generated integer. Like the system is generating keys. And obviously, when we say system should generate keys, we make sure that they focus on it being unique. And it will iterate, either it will be a unique for the some of the tables, and it will be a primary key in other tables. Like we have systems that generate order numbers, they generate order numbers, they generate invoice numbers. So, but the major ones, these two, you may never get to see these two, or you may not even realize that you're dealing with them. But focus on always knowing what is a primary key and what is a foreign key. Guys, I'm not saying that you know their definitions. You should be able to point out what is a primary key and a foreign key in your data. The moment you're able to do that, then well and good. It means that you can easily model that. So,
are there incidents when you're interacting with data that you identify all the 4? The primary, foreign, natural, and surrogate.
You see, when you get the natural, which we're calling natural here, that I added them just to make sure that at least we know about them, but not giving them too much attention. Here I've explained, actually this is common. And there is one dataset I was dealing with another class. We found out that the invoices, there are around 4 invoices that were appearing duplicated. We came out to find that they were duplicated because that invoice went out with 2 lines of products. Now, what do you do when you find this or this? You make sure that you create a dimension table that is going to have invoice numbers that are unique. That is in case if you're going to use like an invoice in your filters, right? But if you're not going to use something like that, we are going to look at that when we reach maybe a visualization. So if you're not going to use maybe an identity in your filters, you don't need to bother about it, then it becomes a fact table, right? It automatically becomes a fact table. But if you're going to need to use invoice numbers, like you need someone to filter an invoice and look at all the details pertaining that invoice, it means you're going to split that table and create a separate dimension table that is only having those invoice numbers. Then you create a unique, or you remove duplicates in the other one. We shall look at that when we come to it. But these ones always will work with them. But at the end of the day, all these 3, when you find them, it will always be a fact table. And with the primary keys, I'm not saying that fact tables don't have primary keys. They do. When you find a sales data set, obviously it has an ID, which is an order number. And the moment you find that the ID is being splitted because of the many product lines that went with that order, then you have to create your own ID, which we said last time you create an index. If you remember in transformation, we said you create an index, maybe counting from 1, 0, 2, 3, 4, 5, 6, then that becomes your ID, your unique identifier. Then you can tell which order is number what. But it is rare to go for that, because you can work with a fact table with it even not having a primary key. Because a fact table will have duplicates of products, duplicate of customers. The order numbers may be split because of the different products that are on that order. So you may rarely have a fact table having a unique ID. But if you need it, there are many ways where you'll find that you need to recreate it. But note the 2, primary and foreign key. Now here the golden rule is what does one single row represent? Obviously, when we look at here, we are looking at the sales transaction. So you'll find that a sales transaction, exactly what I'm talking about, that you'll find that a sales transaction is merging, let's say, an order is coming through with 4 products. But when you load that order into the system, obviously it may show you one line. But when you download into an Excel, where each product has to be given its own quantity, that order is going to appear like 4 times. So it will be forced to appear like 4 times. Then obviously, how do we normalize that? Is by splitting. Maybe you have products alone, the product table alone, such that you mark the product table with the product column in that table. We shall look at that, maybe practically hands-on the other side. So I think I've already explained this. Then I've already talked about the star schema. I showed you the analogy where they started calling it a star. It's always when you have a fact table in the middle and the dimensions table around. And even if the fact tables are more than one, that one doesn't make it not to be a star schema. So hoping here that even if you have, wait a minute. So even if you have more than one fact table like this, then at the end of the day still, even these fact tables will have to get relationships with all these tables like that. So at the end of the day still, the model is called a star schema model. Then the other model that we talk about is snowflakes. I don't know whether I have it here. Yeah, it is. Now, the snowflakes is where you find that you have a dimension table, but that dimension table also has other dimension tables that are not attached directly to the fact table. Here we go. You have a products table, but a products table has a category and a subcategory that are attached to the product. It means here in the product table, here you'll find that you have a column. You have a column for categories. You have a column here for subcategory. You have a column here for categories, and maybe the unique identifier for that product. It means that this one directly connects to that, this directly connects to that. But here in the fact table, you'll only find that you only have product column or ID which connects to that. Now ideally, anything here in the fact table is directly connected to this and indirectly connected to this. That when you start your visualization and you put together a table, you can pick a subcategory here and come and put a value from this side, maybe quantities, and it will automatically give you the answers correctly, even though this subcategory is not connected directly to this. I think that makes sense the way I've explained it. So that we call it snowflakes. Wait a minute. We call it snowflakes. So snowflake schema is not common, but you're going to find it most of the cases, and it always comes with products. It may rarely come with customers, but for customers here, just in case, let's look at this level. You're a company, you're dealing with a supplier, but this supplier has 2 third-party suppliers that supply him, then he supplies you. Like for him, it's just a kayungirizi. So you here in your books as procurement, you don't have the other the other sub-suppliers that are dealing with this one. The only person you have is this. But this person, you signed an MOU that some of the documentation will come in the names of these third parties he deals with, and it is okay with you procurement. But you, in your payments, when you're running payments with finance, running invoices, running LPOs, you run it in the names of this, and is the one who pays taxes. I think that also explains it. So that's where we find now we have like a snowflake. You're running a snowflake because you're having a customer, and behind this customer there are other customers that deal directly with this one, but for us we don't deal with them directly. Then it can also prompt in case that you want to remove this mediator, you as a procurement personnel, because it is your KPI to remove these mediators. Now you want to do analysis with the third parties they are dealing with, whether you can get one and directly connect with them. Obviously in your data you may have them, so it is easy that when I pick the third party this side, I can easily pick the quantities they have supplied and I get the analytics, even though they are not connected directly to these fact cells. But when they supply, their delivery notes come with their names. So we can tell who supplies how many quantities, even though we don't deal with them, they deal with this supplier. I think that explains it better with other analogies. But when you get that scenario, it is a snowflake, but it has its pros and cons. The pro, it saves storage space, because where you would have combined these into this table and create a lot of duplicates, you run with them separate. Then when you're doing analysis, it is done at once. Just imagine that this customer has like 5 suppliers. Okay, this supplier has 5 other suppliers dealing with them. And for us, our supplier table is only having 10 suppliers. Those are 10 lines. Just imagine that the other one, each of them duplicated and brought into this table, and we splitted them by their products they are supplying. We shall find ourselves having now a table with nearly 100 lines, of which we would have had each of them here supplying their 5 products, their 2 products, their 1 product, and all in all, it's not giving a lot of data. So that's what they are talking about here. Then there is adherence to it removes adherence to strict database normalization rules. Last time I told you that the more you divide tables to have other subtables, the more you divide a fact table to have dimensions, putting data that is duplicated aside, we call that normalization. Then when you bring these together into here, what we do with VLOOKUP and XLOOKUP, that is denormalization. So normalization is good for database querying, which is good for this. Now you'll find that if we go back to, just a moment. Okay. Sorry, my thing is becoming slow. Okay. If we go back to Star Schema, just imagine that in this product, there is a column for categories which is repeating many times because of different subcategories. Now, if you removed these 2 categories and subcategories and you put them aside, you're going to eliminate a lot of duplicates here, and that's what we call normalizing. So normalization is what is being done here, and that's the advantage with snowflakes. But now the disadvantage is it requires complex multi-tables to join. You'll find yourself having like 20 tables to put together, but the moment you have done the modeling, it becomes very easy for you to run the report, and the report becomes lightweight. So it can severely degrade analytical query performance. Obviously, at some point, everything too much of anything is always bad. So when you degrade so much, again, running queries becomes hard because you have again to bring them together in your reporting, something like that. Now this is, they call it a Galaxy schema, but it is never common. I have rarely also used it in the data sets I use. Where you find you have a dimension table that links to the different data fact tables, but they are separated. Let's say, okay, if you're dealing, let's bring it to reality. You're dealing with, as how it is, fact sales and fact inventory. Fact inventory can be a report your team is using when they are doing stock take, something like that. So that report and the report for the sales transactions, it means that when you have a dim product or a dimension product, actually dim means dimension, fact means fact. We are going to look at that naming convention, that when you're naming your tables, it is always good to include a prefix of fact or a prefix of dim to easily tell that this is a dimension table, this is a fact table. So what I'm saying here, that the stock take report will have a date which can be connected to the other side of the sales, the same thing with product. So it is sometimes common, but most of the cases you find that the inventory values here are always brought here in the fact cells, such that you no longer run with this completely. You find it is like one column you need here, or to map with the product, to just have the summary of the report that you're running, which we call a Galaxy schema. You find that the dimension tables are relating to the different fact tables. Okay, I think most of the things now remaining, we are going to the next 1 hour remaining. We are going now to do the hands-on. So why I choose 2 hours is always to have a theory on 1 hour, but this time it was throughout theory, then now we are switching to the practical bit of it. If there is any question, please, you can ask. And we can take a sip of water before we kick off.
Question: when you're dealing with the star schema, do you also have to name the way you name in the Galaxy schema?
Actually, it is also another principle now we should take up, that whenever you're running your data sets, why we do that, it is like a standard. You know, a standard in professionalism is like, when I'm not around and someone else comes to work on this data set, they should not struggle. They should have learned this, that when they find a dim, that's a dimension, when they find a fact, that is a fact. Like in other professions where they have principles they use in labeling stuff, the same thing when you come to data set. I'm not saying that if you don't label or do your naming convention this way. Actually, let me first show you. I have this. Now this one is giving the differences which we have already talked about. There is one I wanted us to look at the naming convention. Here we go. Now when you look at this, actually let's first talk about this. The naming convention standards, which we always need to take up, such that even if Chris came to look at your report or to start from there collaborating, or I'm going to edit the next phase, I should know some things with ease. Now here we go. Fact tables, we do a prefix of the word fact underscore, such that like fact underscore sales, fact underscore transactions, fact underscore maybe supplies, fact, wherever you're dealing with. Then dimension tables, we shall always have them with dim, dim and customer, dim product, such that whoever is going to use that data set or model, they know what it is. And also it is easy when you're creating DAX, data analytics expression. When you're searching for a column from a fact table, you just type the word fact on the fact tables, pop up. We are going to look at that when we reach DAX. So it becomes easy also when you have named it right. Then naming the surrogate keys, it can be the combination of either it's primary or foreign. So like you do as underscore, like you start customer underscore key, stock underscore key, employee underscore key, something like that. Whenever you see it, when you're doing your modeling, like how we are going to see how we are modeling here, it becomes easy for you to map up which ones are the keys. Any number can be run as a key, but the moment we name them in transformation and rename those columns, it becomes easy for us to know that this is a product key, this is an employment key. So there is an instance where you'll find that you have a data set, they have an employment key and they have a contract key. Every employee runs with a contract, but every contract comes with a different key. So you find one employee has 3 contract keys, right? But now how do we differentiate them that this is the key I'm going to use? I'm not going to use the contract key maybe in my data analysis because the major is the employment key. So I'm going to rename where there is employment, maybe number, I call it, maybe employment key, such that it is easy for me to pick up when I'm doing the other stages of analysis. So that's exactly, I think it answers your question. So,
yes, thank you.
Yeah, so we turn back to this. Now, shall open our file we ended up with yesterday, the other week, which I think is this, but I can open it from here. So, like we said, reversioning, version control. I don't know whether this class I showed it the way how I used to do version controls. Meanwhile, it is opening. Let me show you how I used to do version controls here. If I can get them with ease. Just a moment. There is a project I'm looking for, which I've run for over 4 years, where I used to do version control. Yeah, here it is. Now, when you look at this, I may not open for the data, but just looking at the versions. So when you look at this, every time I'm creating, okay, before that, this is what I'm going to start with. You see these 3 names? These 3 files, yes, they are the same. But when I'm doing any addition or when I'm working on the file, I will work maybe in the file I will open the test file. I do whatever I'm doing, I test it maximally to know that it is not breaking, it is exactly giving what the client needs, or what they have requested to add. The moment I'm well sure that the test file is okay, then I can save it as staging. The staging helps me that when I deploy it to Power BI One service, it stages on the staging file, not on the real deployed file they are looking at right now. Such that I can go to that staging file online, I also look at it before I give them the final copy. Now when I confirm, which means even I share with them this link of staging, I give them this link to check and get back to me. When the other clients or the teams in the market or in operations are having their file which is untouched. Now when these people in the office and whoever are managing this, they say, okay, all is good, let's go with this. I will now rename this, you know, like doing save as. I save as and I save it as this dashboard. The moment I save it as this and I publish, whoever is having the other link of the production file, they are going to see the changes coming through. Maybe they will have already told them that we have changed this and we shall be giving you updates. But now before I save this is what I do. I run my backups every day. So this is how I run my backups. You see these backups, all these files are the same. But what do I add in front here is the date. You see 2024-08-08. It is always the good way of naming. You start with a year, month, then date. Underscore that. You see this is the name that is the other side. So which means if they wake up one day and they say, no, we needed the other one is better at least. No, let's go back. I'm not going to edit again to remove what I put. I just come to what the backup I have. Then I republish it as to reinstate what they need. You get? So that's what we call version control. Though now Power BI it released an update like 6 months ago that now you can save your files as projects. Then there is that version control. Obviously that is an advanced, we shall come to it on an advanced level. But for now, just manage your versions. Even when you wake up one day, you want to make changes, first save what you did yesterday with its date, the last date when you updated it. You can check the dates when they were last updated. It is the date I put here. It means that on 17th, it's when I was working on the next file. So I saved it as 17th. Then I went to 26th, it's like that. So when you check that even it has been running up to Feb, so I kept changing. And right now I can restore even the file we had in 2024. Why? Because I have all the versions. Though sometimes you may not restore with ease, maybe even the dataset was changed, maybe even the model was changed, but at least you have where to start from. So that's what we call version control. It is very important. I started this after having a lot of issues and experience. So you can start off having that behavior of versioning your data sets. So I think our transformation file has opened. Just checking that it has all the data we had last time. Oh, is this the file we ran with last time? Wait a minute. Let me hope that we saved the file we used last time.
That was on 19th.
Yeah, it was on 19th, but yeah, now this is, I think I didn't save on my end because, but is it still the file we ran with? If I can check, just go to transformation, then we check then we check the advanced editor. Which file was this? This is the file we created last time with AI, the procurement data with errors for us to sort.
Yes.
No, I thought we had run this. Okay. We are going to, so I'll close this without applying. I don't want to apply, so I'll just close. Okay. Now, the files we are going to look at, which means we are going to load another file. So I'll open a new one. So there is a data set we are going to load that has dimensions and facts already, such that it shouldn't take too much time for us. Okay, so I think I will use a file for another session. Just trying to minimize on time. Because we are just focusing on the models, how we do the models, and looking at the cardinality and name them. So it's loading. Okay, this is the table I wanted us to. Then we are going to save it as hours. So I will do save as. That's how even when you're managing your versions, you just save as and have it in your folder, which is this July. Then we shall call this now. It's saving. Now, when we come to the data view, these are the tables we have. Obviously, I'll remove the tables, the unnecessary tables that were just explanatory for the other team, and the fact final, which I also don't need. You'll forgive the delay that is on my end due to the I think my laptop has been on for long. It should have heat up. Now the RAM is so slow. Okay, now when you come to the data view, these are the tables we have. And if I can show you where these tables are picking from, they're picking from this file dataset, which has 4, 5 CSVs and 1 XLS. Actually, you see there is only one Excel workbook and others are CSVs. Loading them is the same way. Transformation is the same way. You shouldn't get scared on that. And all these 4, they are all transformed. They are clean. That's why I needed to have them on this, such that because it is all about modeling. So when you review, that's where you view your data from, under table view, or it is always data view or table view. That's it. Already our data is loaded. Now under models, this is the way how they will load. If I can delete any relationship that is already occurring right now, which we don't need, I will enlarge this.
So question, after you load, you come to models, not tables, right?
Yeah, obviously tables, after you load, everything loads in the table view and in the model view. But here, you see everything in the table view, that's why it is called table view. Then here you see everything in the model view, that's why it is called model view. So which means now, after you have done your transformation and you load, this is where you come. The loading, the click of load, it means that you have commanded your tables to be loaded in your data model. Now this is the data model. This is the model you're looking at. And now these are the tables we have the other side. If I can enlarge them such that we look at all the columns. Looking at all the columns that are part of that. This is the fact cell, which is having that more. So now when you check these tables, you see they are having, I think I'm going to enlarge a bit. I will zoom out later. So when you look at them, you see they have that summation symbol on the sides. You know why the summation symbol is appearing? It's because this column was left to be a number instead of a text. You remember what I told you in transformation, that anything you're not going to aggregate, put it into text, such that it doesn't bring confusion when you go into another stage. Now you see now this city key is having a summation symbol. It means that Power BI is looking at it that it can be summed. You can get the sum, you can get the average, you can aggregate it. And yet there is no reason that you can aggregate a city key. And you get a sum to do what? Does it even make sense? No. So that is the reason why those IDs, the keys, the years that we never want to aggregate, or we are never going to use to do sorting, we always put them into text. This is the reason here. Now it becomes easy for you to know what is going to be aggregatable. It is only maybe for the date or calendar table, where you can always leave some columns as numbers because you use them to sort. Like the month number, you use it to sort the month names, such that January comes first instead of April appearing first because it has A. When you are sorting alphabetically, when you sort by default, April will always appear first on your graph or on your chart. But the only thing you do, you go there and change the sorting. We are going to look at that. So that is one reason I'm giving. So here you look at all these are the columns you have the other side. Now when you come to the fact table itself, when you come to the fact table, you see for it has many because that's where the quantitative data lives. Quantitative data never lives in the dimension tables. We have already talked about that. So me having a summation here on credit limit, it doesn't give sense. Having a summation here on cell employee key, it doesn't give sense because I'll never add the employee's keys to get the sum. So you can always think about that. But even though you leave it as number, it's not harm, but to just make sure that they should never come in when you're doing your aggregations. Then for the fact cells, looking at all that, now the calendar will always show with the calendar icon. Now what you'll not see here in Power BI is the keys, primary key and foreign key showing. But when you go to like databases, like you're viewing it in SQL, maybe sometime I will create a database in SQL and show you. For it, it will always show a simple key here like a primary key or a foreign key. So that's how it appears. Now, before we go further, remember we have said, since we have only one fact table, and we have 1, 2, 3, 4, 5 dimension tables, it automatically calls for a star schema, right? It automatically calls for a dimension that is going to be a star schema, meaning that we are going to put the fact table in the middle, then we put all the dimension tables outside to make it easy for you to have it done rightly. So now there is this technique. If you always want to collapse them, because now we want to rearrange them with ease, right click on one and say collapse all. It should collapse all. Maybe it isn't. I did expand. Sorry. I did expand all. Collapse all. This is collapse all. So which means collapse all. It will be easy for me now to drag this fact in the middle, drag this, put this aside, put this aside. You don't have to be so linear, but to make sure that you're picking everything rightly. So I can put these two here and put these ones here. Why I'm doing this is because I've already realized that the fact table is long. So for me to create that space, that whenever I expand it, I can see all the columns. That's why I'm doing it this way. So here when you do expand all, this is how it appears. So you can always realign. It has no formality that this has to be there hard-coded, but so long as you already know that what I'm dealing with is a star schema. Now if it is snowflakes, it means the subcategory would have been this side at the end. For snowflakes, subcategory, category that are connecting maybe to the product. So here when you collapse again, so you see it's a star. It doesn't have to be symmetric. Why we are not making it symmetric, that it has to be a star format? It's because we also want to look at the rows, the keys when we are joining them. Now, there are two ways how we create relationships. You can always come here on manage relationships. This is on home, manage relationships here. Then there is nothing. Most of the cases, there is an auto detect that will detect relationships and create relationships for you. But here it is only finding one. Why is this one being found? Because exactly the naming in the fact cell and the exact naming of city key in the dimension city is the same. That's why this one automatically picks. But others don't pick because the naming is different. So I'll delete this. You can delete it, but it will always give you a notice that what you're deleting may be connected to a dashboard, and that dashboard will break immediately you delete the relationships. So I'll go ahead and delete that. Then there are two ways you can create relationships from here by creating a new relationship. It will open a box like this. then you select here your fact table, then here you select your first dimension table. Let's say let's start with stock item. Now obviously here it is by default selecting what it wants, but for me in the fact cell I'm looking for stock key, which is here. Then also this side I come and look for the stock key, which is this, right? The moment you select these two, the error that was here has disappeared. Now let me explain cardinality. Cardinality, here we have 4 options. There is many to one, which has automatically selected here. Then there is one to many. These two are the same. The only change comes which table is on the top. This one and this one are always the same. The only difference comes on what did you put at the top. If at the top you put a facts table which has many, it will be many to one. If this is what you put at the top, it will give you one to many as a relationship. So these two are always the same. For now, wait a minute. For now, I'm not going to go into details. Where do they become different? And why do I have to put the other one at the top, this one at the bottom? That is next time. Then there is cross filter direction. This is the arrow we shall always see connecting the two tables. We always use single, and by default we use single. The both and single, I will explain this more when we start visualization. I will show you where they work better. They work better when you're doing filters. That when you filter, are you filtering the stock key from the fact table or the stock key in the fact table from the stock key table? That's the direction which we don't need to give attention right now. Then this has automatically checked itself, make this relationship active. Because between these two tables there is no any other relationship. The day you'll have a relationship between these two, the second relationship you create will never be active. The moment you force it, it will always show you that there is an ambiguous relationship that you're trying to create, that all is already existing. It is like forcing a matrimony relationship in church when you have not yet divorced. That's the same thing. One will never be accepted. Even if you have money, the other one will be inactive. This is active in church. So that is exactly how you relate this here. So I'll go ahead and do OK. It will create the relationship. Here, it will create the relationship, and you go ahead and create new. But this is a hard way to do it. This is the simplest way how we do it. Now, with dimension customer, we know that this is the customer key. Then we come to our fact cell. We know that because you already know these offhead, or you have documented them somewhere. Why? Because you did exploration in transformation stage. Now you get the reason why we click on transform data instead of loading it directly. Even though you're not going to clean, go there and understand what column, each field that is in that table. That when you reach here, should not start asking yourself, customer key in this table, customer key is named as what? Because at some point even I should rename these keys to be the same, such that it is easier for me to map. So there is this customer key, there is this customer key. What I do, I drag this, come and drop it on top of that. It will automatically pop up this, which we did the last time. So the moment it pops up that, everything is okay. And I just go ahead and do okay. Very easy. But it becomes difficult when you make a mistake. Now, let's make the mistake here. We are looking at the employee key. And here we have the employee key. Remember, this fact key has all the foreign keys that connect to these tables. And these keys we are picking from these tables are called primary keys. But when that key comes this side, it becomes a foreign key. Now the foreign key of an employee this side, because for me I've already explored this data, that key is called salesperson key. Here is an employee, this side is a salesperson. You can imagine that misunderstanding. So you calling this an employee key at a go will save you a lot of thinking. So which means if I already click on this and say edit query, I go back to the query. I want to change it for good. So such that I shouldn't be thinking, is the salesperson key the same as employee key? I don't want that. So when I come here, we are going to rename a column. So which column are we looking for? When you don't know where the column is, come here to go to. Then you'll always put here sales and it will come. The moment you click on it, it takes you to that column. Right, like this, it takes you to that column. If you have many columns, you don't need to struggle scrolling. So here I'm going to change this by double clicking there and changing this to employee, like this. So for this data set, they were putting spaces, but it is always good to work with underscore. Oh, I put it underscore. Let me leave a space. So if you want to rename again and you already have it here, you can always rename it from the code itself. You don't need to hassle double clicking and all that. It will rename and the state remains the same. So I'll close and apply this. So when it refreshes, now here we have employee key. Has it refreshed yet? No. The pending changes are still okay. Let's apply. But I think it is applying. Yeah. Here we go. You'll forgive the speed of my laptop today, but it should happen in just a blink. So here it is. It becomes easier for me to drag this and drop it on top of that. Let me see if I can close some things. Meanwhile, if you have any question, please feel free to ask. Okay. Okay, close most of the steps that are hindering me. Now, drag employee, drop it here. Here it is. I'll go ahead and okay. Then we come to city. Here it is city, and here it is city. The moment you map them where they are, drag this and drop it here, right? Okay, okay. You see here it is many to one. Many to one because I dragged from fact table to employee. Let me drag now. Let me cancel that and try to drag from here to here. You see now it becomes one to many because now the other one is on top. This is at the bottom. That's the difference. But I will tell you why did Power BI have the two, not only having one. That reason is also there, and the reason is more into when you go into visualizing. That is to do with the cross filter and the both. So if you selected both here, the reason why you select both is what will explain for us that. Okay, here we go. Now you realize that all the relationships you are creating, here they have a star and here they have a 1. What does that mean? It means that that ID here appears many times and here it appears once. And many to many will be star star. The moment you get many to many, you have to fact check yourself. That is always like a check whether you have an error in your transformation. And it is rare, and there is no reason, it doesn't pick any reason why you always have to have many to many. because it doesn't support you in most of the analytics principles. But scenario may come where you have many to many. But for now, when you reach a point of having many to many, it means that you need to recreate another dimension table to capture in the middle of those two tables. Yep. So we remain with date. Date, we always make sure that we only use date to. Now here we have two dates. So the two dates, you look out which date is primary in your data set. Delivery is primary, invoice is secondary to me, because everything to be invoiced has to be delivered. So this is primary, so it is what I will map first. Then it will take the active and go ahead and do save. Then why do I also need to map the invoice date? That at some point, if I'm going to create a page and put report for invoice date, will this date still be connected to the calendar? No. Just connect it even if it is not active. You see, automatically it doesn't check this because there is already a relationship. And when I force it, it is going to validate here and tell me that there is an ambiguous path between the fact cell and the dim date. Why? That there is already, like the example I gave you in real life. You have already married in church, they accept one. The moment you go back, they tell you, we haven't seen the divorce letter for the other person before you bring in this. Which means if I go and check the other one, this one will accept. But as long as this one is not, the other one is not yet, this one will remain like that. So I go ahead and save. Now when you save these two, I want to enlarge here. Just a moment. Yep, yeah. When you look at these two, you'll check that one of them, where is the invoice? So you'll see that one of them is dotted, another one has a thick line. So any relationship that is not active will always be in dotted line. But it is not a problem. But still, you have to minimize on dotted line relationships in your data model. That one also you have to note it. If you have many things that can relate to a table in dotted lines, it means that you're lacking dimension tables. Split this table and create another dimension table that will reduce like 3 dotted lines you have created. So here, when we look at our model, here we go. So if I go ahead and collapse this, you look at the model, that's how it is. So at the end of the day, you look at this, it is exactly the star we have been talking about. And this is what you do in data modeling. It seems to be simple, but it is always done with a lot of sensitivity. Just imagine that when you are modeling, creating a data model, instead of relating the city key to the dim city, you related the city key to the employee. Do you know that there may be a city that has a key of 122 and there is an employee of 122? Power BI is going to see as if it is normal. It is okay. Maybe it thinks maybe the headings were different. But when you reach doing visualization and you're filtering out employee, that's when you're going to see things messing up. You're going to see the poor performer you all know on that team is the one picking good numbers, not knowing that you're picking him as a city, not as an employee. So you have to be keen when you're creating this. And how keen will you always make it to audit yourself? Just open it from the manage relationship and read them from here like this. But on top of that, in exploration, when you're doing transformation, make sure that these keys are given the same name, such that when I'm auditing here, I just look at this: city, city, customer, customer, date, date, employee, employee, date, date, stock item key, stock item key. Easy. But just imagine here you have product key, here stock item key. You have maybe SKU, you have product. At some point, that confusion, whoever comes on board to look at this as secondary, they will get challenges. Okay, now let me go and show you. We still have like 8 minutes to go. Before we go to other, let me collapse this, right click. Okay, I think here, yeah, collapse. Okay, now when you look at this semantic model, I talked about this. Somewhere you'll find it called semantic model. So when you look at this semantic model, it gives all the parameters that are always included in the semantic. So on the parameters, calculation groups, maybe in an advanced stage you'll just get to know this, but for now you can always research about them. Calendar, we don't have a calendar right now. We don't have a table that has been noted to be calendar. Then we have a culture, which is the language we are using. We are running on US. Expressions, with the other team, we had done model merging and appending. So I think that's why these expressions are coming. Then here, the functions none, measures none. This is now the DAX, our next session. The relationships are here. There are 6 relationships. And when you open them, they all show you these relationships. And you see where there is a slash here? This is the inactive one, the dotted one. So you can easily look at, get your relationships from here. Which means if I want to take this into AI, to have more descriptions, or maybe as how we are going to do next week, using AI to create for us DAX, you can always screenshot this. AI will understand how your data sets are connected to each other. This is a complete model. Rather than giving it this, you can also give it this as a screenshot. The roles, we don't have any role. And the tables, we have 6 tables. So that is the semantic model. Now let's go now to our visuals. We run some tests. Now, we are going to create a table. I'm going to create a table. Then on that table, I'm going to look out for customer name. Better when you have more than one table, you no longer need to expand and scroll to look for a parameter. Just search for it. This is it. I'll put it here. Then I get, I don't know, what, do I have quantities? Something like that. Do I have quantities? Yes, quantities here. So I'll draw quantities and put them here. Now, when I remove this search and click on this table, actually I needed customer name, not customer ID. Customer name is here in the key, in the table for customers. So when you look at this, you see that every customer has picked their own price, which is okay. They have, sorry, now this is quantity. They have picked their sum of quantities they do, which is okay. And what tells you that your relationships are doing well is this. That you're picking the qualitative data from one, this is the customer name, from one table, and you're picking the quantitative data from another table. These 2 tables are separate, but they can communicate and give you the data this side because of the relationship. Now let's go and cancel that relationship and you see what will happen here. If I can screenshot this, no, we shall see the difference. So just looking at the data, every customer is having different numbers, and the total we have 10,286,70. So let's go to the relationship again, the data model, and we cancel the relationship between customer and the fact table. We delete this, just assuming that it never existed. But remember, the report or the visual we have is connecting a customer name with the quantities they have this side. But these two things are not connected. So when we come here, this is what you see. The customer, every customer has picked the total of quantities you have in the whole business. You get? So when you see this, know something is wrong in the model. There is a break you have got in the model that you need to look at. And most of the cases when you're doing presentations, never touch your back end in front of the audience, because the moment you go into the back end to change something, things will break and you don't have the mindset together to make sure that you look at where the problem is, because you're looking at solving something in the meeting, and the moment you do that and things break, the more users lose integrity to the data set or to the report. So never do that. You can always tell people, I'll get back to you, let me look out something. And, or let me drop my screen, someone else can take on the presentation, I will present again in the next 2 minutes. You go, drop your screen, do whatever you're doing when your mind is together. But when you're editing something, people looking at you, waiting to hear from you, everyone is silent in the room, you have that anxiety to make sure things work. It is always a burden. And when it comes to DAX expressions, you have an error, you don't know where the error is coming from. So never do that. That is a principle you will always have to take in presentation. So this is it. So how, since I know already what has happened, you go back to your model. You can even come here and look out whether there is a relationship between customer and fact. Nothing. Then you can say, create that relationship between the customer and the fact cells. Then I look here for the customer key, look for the customer key, and go ahead and do OK. And the moment it is done, this table automatically refreshes. So you see now the purpose of modeling when we come to visualization. Whichever visual it is going to break the moment the relationship breaks. Now, here they are telling us that we don't have a calendar because the table we have here is not marked as a calendar table. It is just a table, yes. Here it has dates. It has a date, it has a date number, everything. But it is not a table. It is not a calendar table. So when you click on it and you come maybe under data model, no, it is under data view. So there is calendar options here. Why we do this? Before you mark your table which has a dates, or even if you call it calendar table, as long as you don't do this, mark it as a date table. You'll never do analysis like year to date, month, those time intelligence analysis. You'll not be able to do it. Even the DAX you'll be doing will be breaking. So you come to calendar options, create a calendar to improve query performance as you analyze data over different periods of time. So here you come and add that new calendar. You look out for the table. Where is our table? It should be here, dim date. This. Select associated columns. Okay, I think we shall have to do this in DAX because now it necessitates me to take into another stage of creating a table, just assuming that this table we never had it. So we recommend validating the before saving. So this one is not being recognized. Let me see. Here it is. Okay, it is. But there is another option we shall go through when we are creating a new calendar table. But here we have it here. We just come and mark this table as you tick on this, mark it as a date table. Then you select the column that is primary for that calendar, which is always the date, and it will always pick automatically from this table. So date, then validated successfully, then you save. And the moment you save and do done, so automatically now this table is being marked as a calendar table, which means you can do all the other computations with ease. That is something that you shouldn't forget, or you can even always remember and go back and mark it. So when you come to this, you always find that it is on and the table is marked done. Any question? I don't want to take it above or from here, but just reviewing with what we have.
How come we've not been done the expressions?
The expressions, that's another session, and that session takes like 4 hours. So we shall do it because even another class has done it once. These are the expressions here. DAX and analytics. So DAX and analytics come after data modeling. So data modeling, we have done all this. We have looked at all this. Building a calendar table, we shall just look that into details when we start DAX. Then naming, I've talked about it. The AI assisted, you can always, when you give your framework of all the data sets you have. Framework, I always mean the headers and a clear explanation of their data types to any AI tool. It will give you a finished relationship model that will be easy for you to copy replica as you model. But obviously you just need to know the basics, like what we have done. If you don't know what we have done, even if AI gave you that, you may not tag them with ease. So that is the way how you can use it. Or if you have big data sets, you can also use AI. If the company is using like Copilot can always give you a list of relationships you can create. Then it becomes easy for you not to look around when you go to some data models. If I can show you before we close off. Let me show you with some data set I have here. So when I show you, there is a system I have. Whether I have an ERP system that I'm rolling out. But here what I want to show you is the data set it has, the way you look at the data model. So let's look at the database for that system. And we look at the tables. No, let's look at the schema visualizer because that's what I want us to look at. Now, systems have the same schemas we have looked at, but they have a lot of tables. Now, when you come to this schema of mine, you'll find that my database has, the last time I checked, it had around 70-something tables. Those are many tables if you pulled them in Power BI. So that's why you only pull data that you need. So when you come to a schema visualizer of a database like this, you see it is a long one. And what you're seeing here is what I was telling you. Let me see if I can. Here, what I was telling you, when you go to the database itself, you'll always find there a key. You see this key? This now is a primary key. It means that in the stock take lines, this is a primary key. And whenever it is, when I check the relationship, you see when I click on it, whatever is annotating here, like whatever you see here is the relationship, it is sending into other tables, different tables. If I double click on that, you see it is a primary key sending in a different another table that is so here, which is I think a stock ID here. So you'll find that a system has a schema that is so complicated, but when you come to Power BI, you have to always put it right, and you deal with tables you only need. You don't pull all the tables for the company, like how you see this. There are very many tables, and I never needed all this data, which means when I start picking data from these data sets, this database, I don't take everything. I just only pick the tables I need. Like the table I need is what I take. You see, there are some tables that have 17 columns, but do I need all the 17 columns? Something like that. So you only pick the ones that you need. What you don't need, you leave it. Some tables have you see 35 columns, companies. It means it is giving all the details of the company. 35 columns, which we may not need. At the end of the day, we may not need all this. Okay, if there is any question, please go forward as we prepare to drop. Just checking our recording. I think this has been an interrupted recording ever. I will have to stop this.